All right, this question comes from Justonecubeofice from the LearnMath subreddit. And it says the points are negative 248 and 0, 3. And he needs to find an exponential model for this. So we get to make some arbitrary choices of the base. I'm going to use e's for the base, because why not? And we have negative 248 and 0, 3. 0.1. Okay, so I've got an equation of the form, let's say, a times e to the bx, okay? And I need to know what this b and this a mean in order to give a function that fits these 2 points. So let's take this one first. Let's take that point first, because 0 is for x. So we can plug in 0 for x, and then we'll get a e to the b times 0, right? But this is just equal to a times e to the 0, and anything raised to the 0 is 1, so this equals a. So when x equals 0, a equals a equals 3, okay? And you know that because it's the y value here. And actually, maybe I should state that a little bit better. Let's go. So from the same equation, a, e, b to the x. Now, this equals y. So when x equals 0, the whole equation equals y. So a, e, b to the 0, b times 0 equals 3. Okay. And then b times 0 is just 0, and e to the 0 is 1. So a times 1 equals 3. So a equals 3. Does that make sense? Now, we know a is equal to 3, so we'll just plug that in. So 3e to the bx. Now we use the other point. Okay, this equals y. So we have 3e b times negative 2 equals 48. So let's take the natural log of both sides. We'll get natural log of 3e to the negative 2b equals the natural log of 48. And then we can use this log rule to break this up into a sum of 2 logs. So it'll be the log of 3 plus the log of e to the negative 2b equals the log of 48. And I'm just going to bring it over here to keep working on it. And so I'll subtract the log of 3 from both sides, and I get the log, or actually, yeah, let's just do it that way, of e to the negative 2b equal to log 48 minus log 3. But this is the same as log 48 divided by 3, and that's just a log rule. And then the log of the natural log of e to the anything is just is the exponent, right? This log is the inverse of the exponential function, so those cancel. Now, 48 divided by 3 is 16, so this becomes b. Actually, I'll just do it at another step. This becomes log of 16, and then we divide by negative 2, and we get b equal to negative log 16 divided by 2. And actually, I think we can simplify that. Let's see. So this is negative 1/2 times 16. So that's log of 16 to the negative 1/2. Does that make sense? So this would be equal to log of 1/4. Yeah. And so this equals log of 1 minus log of 4. This is all equal to b, keep that in mind. So b is equal to, so log of 1 is 0, and then 0 minus log 4, so yeah, so we get negative log of 4. And you can plug that in, let's see. Let's plug this into our calculator. I imagine you have a calculator. So this equals, for the exam, I mean, negative 1.386, and so on. And that's where that number came from. And I think you had figured that out from the multiple choice. So a big thing with these is just like, don't panic. You know, exponential functions and log functions are actually kind of hard. You haven't really been thinking in this way before. And you have to go back and remind yourself and convert things back and forth from the log to the exponential function notationally and say like, okay, this is what this means in the exponential function. Okay, that's what it means in the log function. And remind yourself to kind of get you through it. These are not easy, and anyone who just like is sort of glib about that is doing you a disservice. These are hard. So take your time, pat yourself on the back when you get these small victories.